Suppose A is real matrix with non-negative eigenvalues and B is real matrix with eigenvalues of absolute value less than 1. It means what is said? A is real matrix and eigenvalues of this matrix is non-negative. It means 0 and positive eigenvalues are possible, and eigenvalues of B, it means absolute value is less than 1. Now there are four statement first, second, third, fourth, and we have to choose which combination of these statements are true. For first statement, as eigenvalues are either 0 or positive, so recall one theorem. If eigenvalue of matrix A is given to you and we have to find eigenvalues of I plus minus A, then we have to add only 1 to each eigenvalue of A. It means if eigenvalues are 0 and combination of positive value, if we add 1 to all these, then we cannot get, or never we will get 0. It means no eigenvalue of I plus A is 0. It means this matrix is invertible. Statement first is true. As I plus B is invertible, this is statement second. Because of eigenvalues of B having absolute value less than 1, it means eigenvalues lies between this interval, suppose represented by lambda I. Then after adding 1 to each eigenvalue, 1 to each eigenvalue, 1 plus lambda I never be 0, because of whatever value we choose for lambda from this inequality, we will never get 0. It means I plus B is also invertible. Now statement 3 for I minus A, because of if eigenvalue of A is 1, as you can consider A as identity matrix and I minus A will be same I minus A, then eigenvalue will be 0. It means I minus A is not invertible. Statement 3 is wrong. I minus B is invertible. Similarly, as we already mentioned, reason I minus lambda I for matrix I minus B never be 0. So I minus B is invertible. Now we have to choose which combination is true. First, second and fourth. Option D is correct and other one are wrong.